Welcome to qnawire.
Okay, we've got two considerations here. Right, so we've got basically a low energy plate, right, and then three other plates, right. Let me do a better job here. Okay, which have various sizes and energies, right? So we can just kind of say this is low in terms of energy, right? Um, And if we wanted to rank these, we could say, maybe this is medium energy, this is low energy, and this is high. And if we wanted to quantify the energy, we've actually got 11 high energy zones or medium energy zones for A, right? We could say maybe there's a total of 330 in terms of energy there. And there are likewise 11 for B, so maybe we could say the energy here is 110. Okay, and then for the high, there are 7, high energy zones, totaling 350 energy. Whereas for this dish, the one we're starting with, we total something like 40. Okay. So the question then is, which of these dishes would make the food dish the warmest when placed atop it, right? Well, just in terms of total energy available, C is, obviously the best, right? Uh, C has the most energy available. There's 350 energy on dish C. A just doesn't have the same amount of energy, and neither does B. So without considering size, it seems like C would be the best answer. So on the basis of purely looking at energy, we're thinking C. But what about size? Okay. So it's worth considering that contact between the upper and lower dish is going to matter, right? So for example, we could imagine a scenario where C instead had the size of A, right? And here, suddenly, if we brought the whole thing to equilibrium, the size and considered energy transfer rates, it may take longer, in fact, for C to transfer all of its energy to our dish than A would if A had a higher amount of energy in contact with C, right? But in terms of total energy and size, C is the best, right? C is the same size as our food dish, right? It's going to overlap perfectly with it. There's not going to be any energy loss to the ambient air. There's not going to be, we don't really have to worry about uh, thermal properties of the dish itself and transferring energy within itself, right? So on on the basis of both factors, let's say that, C is the best answer. Okay. Now, we've got something else to consider here. As part of your answer, explain how the energy and temperature of both the top dish and the food dish will change when the food dish warms up and why. Okay, so essentially what we're saying is that we've got this low energy dish and we've got a high energy dish that we're putting on top of it. Okay, so what do we know about the flow of energy when two things come into contact? We know energy flows from high energy places to low energy places, right? We should expect the flow of energy from the top dish, which we're calling C, to our food dish on the bottom, right? So we should expect that the energy in C, let's call it EC, to go down, right? Which means that the temperature of C will go down, right? As energy flows from C to our food dish, the temperature in C will go down. Now, we shouldn't expect energy to flow from the low dish to the high dish. We should expect energy to be received in terms of the low dish, right? That is, if we talk about our food dish. So the energy in our food dish, which we'll call EF, should increase likewise. So too should the temperature of our food dish increase, right?